Yes, thank you.
Okay. So, hello, everyone. This is Warren Redlick. I am here with David Wilshaw, a Florida geologist. We're going to talk about tunnels in Florida, which I think is a fascinating topic. David runs Britannia Solutions LLC. You will hear that he does not sound like a Southerner. He's from the Southern United States. He may be from the Southern or Northern UK. He obtained his master's degree in foundation engineering in 1987. He was a geologist in the United Kingdom for 16 years. He's been in Florida since, I believe, 2004. Is that correct, David?
That's right. Yeah, I came in just as Hurricane Charlie arrived. That was me.
Okay, so you've experienced our lovely weather.
Indeed, for many years. Yes.
And more importantly, you've experienced our lovely ground. I should have mentioned to you, I have a few photos I'm going to pull up that you probably won't see, and I'll tell you when I'm pulling them up, just so other people can see them.
Okay.
There's a photo of the Golden Glades interchange from like a map picture of the Port of Miami. Sorry, there's a picture of Proof Rock, which is a tunnel boring machine that the boring company uses, and there's a picture of a sinkhole. So let's start with sinkholes, because people who aren't familiar with you and aren't familiar with Florida might not know about sinkholes. I'm going to put this sinkhole picture. This is from your website. It's like a road that's collapsing. It's on the main page of your website.
Okay.
So what are sinkholes, and why do people care about them?
Well, Florida is a pretty unique geology, really. We have the whole state is underlain by limestone. Limestone is a rock it dissolves in acidic groundwater. So the rock is kind of like a Swiss cheese as you're close to the top of the rock in particular. There's lots of cavities in there. There's lots of holes in there. And then that's why we have such a great aquifer in Florida, is because the rock is very porous. It holds a lot of water. The Floridan aquifer is one of the best and largest aquifers in the world. But that comes with a problem, because when there's holes in the top of the limestone, then you can get interaction between the rock, our bedrock, and the soil which sits above it. So the soil can collapse into these holes in the rock, and then that makes itself into a surface expression of a sinkhole. So it's really just that interaction between the soil moving into these cavities in the limestone. So it's something we live with. I mean, that's why we have all the lakes that we have in Florida. A lot of the lakes are sinkhole lakes, where the ground has collapsed into the limestone and left a dish in the ground surface which fills with water, and it's a lake. So all our lakefront properties are really sinkhole front properties. If you've been being honest about it, but sinkholes are something we have to deal with, but the flip side of that is that we have a great water supply,
right.
And you can't have one without the other, So
right, and your business is, if I want to build something somewhere, I want to make sure I'm not building it on something that's going to become a sinkhole, right?
Right. I mean, you can do so much. You can do so much to kind of assess the risk, and you have to explore the ground. We use geophysics, we use drilling, we take samples of the soil and rock, and we try and assess the risk. Sometimes even an old sinkhole can have bad soils in there, because if you imagine when the ground collapses, it creates this circular lake, which we're so familiar with in Florida.
Yeah.
There's no rivers running through it to clean out the sediment that collects at the bottom of that lake. So you get lots of organic material. So even old sinkhole, even though the sinkhole is gone and it's extinct almost, if you like, we have these very poor organic muck soils, as we call them here. A peat or a very compressible and decomposable soil which sits where the sinkhole made that kind of dish depression in the ground surface.
Okay, so the reason I wanted to talk to you is I told you this. We talked briefly before we started. I'm fascinated by the potential for the boring company, Elon Musk's boring company, to make tunnels that will, as he puts it, solve the soul-crushing traffic problem that we all have. And we're going to talk about some of this later. A simple example is just I live in South Florida in Boca Raton. We go to Miami sometimes. When I have to go to Miami, I have to go through this Golden Glades interchange, or there's some other way down, and it always gets jammed up on the way in. And the theory is that if we were able to do tunnels that go under the surface, we could alleviate our traffic problems. It could be a tunnel into Miami, a tunnel go to the Keys. It could be, and I think of it all from South Florida because I live in South Florida, but high-speed tunnels to popular destinations like Disney.
Right.
Where somebody in South Florida could hop in a tunnel, be at Disney in a half hour, and enjoy their day and not have to stay in a hotel in Orlando and come home that night.
Yeah, day trip. Yeah.
So, what are the challenges of for the folks who are watching? The idea was David is Mr. Wilshaw is an expert on tunneling, and I'm sorry, on geology in Florida. So, what are the challenges of tunneling in Florida as compared to other places?
Well, let's just talk about what tunnels are there for. So tunnels are a part of our infrastructure that's used. If you can't go over it, something or around it, you've got to go through it. You drive through it. So a tunnel is they've been used for hundreds of years as ways of making direct routes through difficult topography. So hilly countryside, mountains, there's tunnels that go through the Alps. And so we don't really have that kind of topography in Florida. It's a relatively flat state. The highest point in Florida is only kind of 300 feet over sea level. So we have some kind of undulating surface. If you come to Central Florida and the Lake Wales Ridge, it looks quite hilly, and parts of northern Florida are quite hilly. But it's not insurmountable for us to be able to take a road or a railroad, with a few cuttings and a few embankments. We can kind of flatten things out. So that's really why we don't see many tunnels in Florida, because it's relatively flat ground. It's not that the geology is okay to tunnel through. It's challenging. Any tunnel is challenging. A tunnel, you're driving through ground which you can characterize to a point by doing what I do. The geological assessment. You drill borings. You find out what material we're going to go through. You tell the tunnel boring machine, designer, this is what you're going to have to drill through when you're drilling this tunnel. So he'll design the tunnel boring machine to, cope with those types of ground conditions. But, it's not insurmountable. It's risky because we maybe do a borehole every, 300 feet or so, and there might be something in the middle which, we didn't anticipate, because geology is like that. It's not nice layers of soil and rock that we know exactly how it's going to behave. It's nature. It's natural material. It's unpredictable to some extent, which is why we do what we do as geologists. We try and make that assessment of how difficult it's going to be to drive the tunnel. But Florida, it's relatively soft rock. I mean, we call it, the Florida limestones are really called an intermediate geomaterial. They're neither soil nor rock sometimes, so it's hard to characterize it, but it's pretty soft going. If you're driving through hard granite, that's a big effort to drill a hole, to put a tunnel boring machine through a hard granite. But really, our Florida soils and rocks are pretty soft. You can get through them pretty quickly. So there's not really a technical challenge, really. It's just more that it's not common because we've got a relatively flat-lying state, and we don't necessarily need to go up. We can go over things, or we don't need to tunnel through them.
Right.
Now, that's not to say it's not a great idea, because because you can put infrastructure down below existing, built development. We can take it underneath. Why do we need to have highways and even railroads that go, on the surface? You could certainly go underneath the infrastructure. Again, it's probably more expensive, I guess, and that's the thing, isn't it? It's if you're doing something that's different, though, like the boring company with a hyperlink, that's a really quick transportation system. Well, then it's probably worth the effort and the expenditure to bore through the soils and rocks we have here.
Right. So, so we do have, and I'm going to put this up on screen. We do have the Port of Miami. For those people who think there's no tunnels in Florida, the Port of Miami is a tunnel that was built. I don't know if you guys can see I don't think you guys can see my mouse, but it's a tunnel that was built that allows people to get to the Port of Miami going underwater, going under I guess it's the Bay of Biscayne. I think Biscayne Bay.
Cut it goes through, yeah.
So, and it's a fairly short tunnel. I believe the tunnel portion it's the part that's underwater for people who are looking. I believe it's less than a mile long, and it's 2 tunnels. Does that sound right?
Yeah. It's a twin tunnel, one each way. So yeah.
So I guess the theory is just for people who don't know, there are tunnels in Florida. There aren't necessarily many of them, but there are tunnels. It is doable. And I think you told me, I could be wrong. Did you tell me you had some connection to that project?
Yeah. We worked. I worked as part of a very large project, but I spent some time characterizing the soils. The company I worked for at the time did all the geotechnical drilling and testing there. So yeah. I mean, it was. again, it's a very short tunnel, and it's very steep because it's a short tunnel, but it has to go deep. The reason it has to go deep, I think the top of the tunnel is like 60 feet below the seabed there.
Right.
But it was future-proofed for them being able to dredge government cuts there to allow larger ships to come through. And that's all kind of linked to the Panama Canal being, extended and larger, not just cruise ships, but, larger sort of freight. Yeah, Panamax, that's it. Yeah. So it had to be deep for that, really. You couldn't, build a tunnel that you couldn't dredge any more sediment out because you're going to, dig the tunnel up. So it's kind of if you've ever driven through it, it's an up and down. It's quite steep. So that was much of Florida geology. Florida's got very young rocks and soils, really, in geologic terms. There's I think the oldest rocks that outcrop near the surface are only 30, 40 million years old, and I kind of glibly throw that out there as a geologist. But I come from the UK, where there's rocks that's 1,000 million years old. you can go and look at, but here it's relatively new. And it's never been subjected to many what we call tectonic forces. So if you're familiar with like plate tectonics, plates come together, they crush the ground, they make mountain ranges. We've never really had that in Florida. It's relatively stable. So most of the soils and rocks are horizontally layered. It's pretty easy to do. When you have a steep tunnel, though, it's going to go through those different layers. So you're going to encounter different rock materials and different soil layers. And the Port of Miami tunnel had one layer that was particularly soft. And it sounds crazy, doesn't it? I just said to you before, if it's soft ground, it's much easier to tunnel through than going through granite. But there's very hard layers. There's a Miami limestone, the Miami oolites. It's relatively shallow, so that's a hard one you've got to get through. And then you get into kind of a sand with shells in it. It's just like the beach sand, but it's really weak and loose. So some of the challenges with the Port of Miami tunnel were that you had to strengthen the ground to be able to tunnel through it. So you had to pump concrete in there and stiffen it up so the tunnel boring machine, which is designed to go through this very hard layer and then hits this really soft layer, you kind of make the soil a bit harder so that the tunnel, you don't have to kind of change, TBMs halfway through the project,
Right. Well, I guess that's one of the challenges. But you mentioned 60 feet below sea level was the top of the tunnel. And something that the boring company talks about is they believe they need their tunnels to be 2 tunnel diameters below ground level. The top of their tunnel should be 2 tunnel diameters below ground level. And if they do it that way, number one, I think the tunnel is more stable. And number two, people at ground level don't feel the tunneling and they don't feel the operations in the tunnel.
Right.
Does that sound right?
Yeah. So, I mean, if you're excavating anything at the ground surface, you have to be aware that, you might impact what the ground above is doing. So you have to have enough soil or rock above the crest of the tunnel that you don't get even a very slight deflection can cause somebody's house to crack.
Right.
It doesn't have to be very much. It'd be, fractions of an inch, and you can get some damage. One of the problems we have with maybe tunneling through particularly urban areas like Miami is where you go. Skyscrapers in Miami are on very deep foundations. They're on piles which are maybe 100, 150 feet down. So again, that's a challenge for a tunneling company. Even though you can get away with having 2 tunnel diameter of cover over the top of the tunnel, what happens if you've got to go under a building which has got piled foundations 150 feet down? So then you what do? You skirt around it. The Elon Musk idea is a straight line. It's a fast way of transportation.
Right.
And, you don't want bends. You don't want to have to weave our way through at high speed and make everybody sort of travel sick on their way through.
Just to clarify, my understanding of the boring company's plan is there are hyperloop tunnels, which you want those to be straight because you're going 600 miles an hour in theory.
Right.
Then there are the local tunnels, which they don't have to. I think the top speed in the local tunnels would be more like, they call it loops and hyperloops, or loop and hyperloop. The loop tunnels, I think the maximum speed is 150, and of course you can slow down for curves.
Right.
So I do think it's more flexible within the city, and then there would be some spot where the hyperloop would connect, and the hyperloop would be the faster tunnel. And I'm pretty sure you don't want curves at a 600 mile an hour tunnel.
Yeah, imagine that.
So one of the things that I think I read in the Boring Company FAQ was the depth is dependent on how hard the rock is above. So if it's softer rock, you might need to go deeper.
Right.
Does that make sense? Because you're going to be more likely to transmit vibrations through softer material than hard. I'm not sure exactly what the issue is, or the material is more likely to cave if it's softer.
Yeah, it's more likely to deflect. So it's so when you're removing material, when you're boring a tunnel, you're taking material out. The ground above is going to strain a little bit, and you're trying to avoid that. The tunnel boring machine, keeps that intact. But if you've got very weak soils, then that strain can go all the way to surface. If you've got some very stiff or strong layers of soil or rock above you, that acts like almost like a ceiling, like a roof that will spread the load. As you remove material away, it makes this what's called a pressure arch. The soil kind of gets stronger as it arches over where you've taken the material away, and it's strong enough that you don't get any impact at the surface.
Okay.
But if you've got it's almost like a sinkhole forming. The sinkhole takes the soil away and it moves it into a hole in the limestone, and everything then strains down, and you get not necessarily a hole at the surface, but you can get sinkhole damage to houses just caused by the movement of material and the strain of the ground as it kind of deflects in towards where the sinkhole is forming.
Okay.
So yeah, I mean, that's a great point for Florida. We do have some pretty weak soils. In Miami, we've got the Miami Oolite, which is a rock, so it's a relatively shallow rock, and that will act as like a nice kind of ceiling layer, and like a stiff layer that you could tunnel underneath it and you wouldn't feel anything at the surface more than likely.
Okay, just so you know, there are people, there's a live chat and people are asking questions. I'm going to get to a question from a friend of mine. I actually interviewed Will he has a channel on YouTube called A Boring Revolution.
Okay.
And he follows the Boring Company closer than I do. So he had a question, but just for those of you who are not familiar with Florida geology, we talked about sinkholes earlier in this conversation, and I live in South Florida, which is Palm Beach County, Broward County, Miami-Dade County, and probably the Florida Keys. And we don't really have sinkholes here, and maybe it's because of what you're talking about with the Oolite. But a large other part, maybe most of the rest of Florida or large chunks of Florida do have this sinkhole problem. So what is it about South Florida that we don't have sinkholes?
Well, again, you've got the Miami limestone or Miami Oolite, which is a relatively young. It's only a few 100,000 years old. It's a really young rock, but it's like a coral reef. But it is strong. It does have holes in it, and you can sometimes get sinkholes in South Florida, and it's pretty rare.
It's rare.
But if you've got, you can have holes in this limestone, which will accept some soil and can cause some deflection of the ground surface. But, you're not going to get the ones you see on the news, or the ones you see on my website, where the ground is just gone, In probably the most prone area is probably west central Florida. So, around about Tampa and north, and those Pasco, Hernando, and Hillsborough counties probably have more than anywhere else, really.
Okay.
And they're the limestones maybe 30 feet down. And you've got maybe a couple of layers of clay and then some sand on top of that. So you haven't got, it's almost like a fuse, It's like you've got this problem that the holes in the rocks have been there for, millennia. Limestone does dissolve, as I said to you earlier on. It dissolves in acidic groundwater, but it only dissolves at a rate of, an inch every 1,000 years. So it's not something which is sitting there kind of fizzing like a big Alka-Seltzer underground, dissolving away. It's a really slow process. So the holes in the limestone have been there for millennia. But what happens is they do get slightly larger, and then you can get changes in groundwater conditions. You have storms coming through, and high and low groundwater, drought and storms upset the balance of the way the soil above the limestone feels. And then some sudden events happen. There'll be a collapse. Sometimes the soil again is kind of holding on and bridging across the hole in the limestone, but then suddenly it will give way and you get a sinkhole at the surface. And because we've only got 30 feet of soil, then if your limestone is 100 feet down and that happens, you maybe get some disturbance, almost like what we're saying about the tunnel. A couple of diameters above that, it might disturb the soil, but there's enough soil above it that it will kind of, same as a tunnel, you're able to span across it and accept that strain in the ground without it affecting the surface. Well, you only got 30 feet of soil over the limestone, then you can get some damage or a sinkhole forming at the surface.
Okay, so real quick, there's a couple questions about monetizing the tunnels, and I don't think I didn't have David Wilshaw on, a geologist, to talk about monetizing tunnels. I mean, if you want to talk about it, we could, but I'm really more interested in the practical issues of tunneling, and maybe we'll talk about that towards the end. And Glenn Cook asked about whether it's possible to do a tunnel to Disney or Port Canaveral, and I believe the answer is yes, but we're going to get to that, Glenn. And A Boring Revolution Will asked this question. Hi, David. In Florida, are cavities in the limestone less prevalent over 300 feet underground? What is the prevalence of cavities and holes in the limestone?
Right. So that's a great question, and it's probably the top 1,000. I mean, the limestone in Florida. There's 3 miles of limestone underneath Florida. It's a bizarre thing. We've got a very peculiar geology in that we were formed by an environment very similar to the Bahamas today, where you've got shallow, clear water, lots of organisms, because that's what limestone is. It's it's a biological deposit, if you like. It's a biochemical material. So it's animals that live, procreate, then die and settle on the seabed and form a kind of a carbonate-rich ooze, which then eventually solidifies into limestone. And because of where we are, we've been generating limestone for millions and millions of years. So there's 3 miles of it. The top, where we get our water from, our aquifer, the top probably 1,000 feet is the most porous. It's the easiest to get the water out of. The reason that limestone dissolves is it dissolves in acidic fresh water. So it's impacted by rainfall, which dissolves carbon dioxide from the air, and also, as it passes through the soil, it picks up humic acid from the soil. So that puts its pH down to 5. So then it will dissolve the limestone. So all that action really is happening where the acidic groundwater hits, which is close to the surface. So the deeper you go, there's less of the cavernous limestone we get. But again, it's 3 miles deep. There's a lot of it. But the upper surface is more porous and more cavities in there.
So how far down would you have to go before they become rare, before they become much more rare?
And we have very few borings that have gone that deep. We don't, less than probably 150 deep boreholes in Florida geology. There's a lot of wells that explore the top 1,000 feet, but I would say 1,000 feet is where most of the productive zone of the aquifer is. If you're going for a municipal water supply well, you're going to get clean water there. If you go any deeper, you get salt water, because we're a peninsula surrounded by seawater. So the deeper you go, the more brackish and more saline the water becomes. But yeah, I don't think you're going to, from a sort of an engineering or practical construction viewpoint, you're not going to get, into limestone where it's complete solid rock that you can tunnel through without finding a cavity. It's just not. It's going to be too deep. Okay.
Does it matter? I mean, if you're 100 feet down or 200 feet down and there's nothing significant above you, does it really matter if a cavity, does that just make it easier to tunnel through, or is there a problem when you find a cavity?
Yeah, I mean, it's challenging for the tunneler because, again, you design a tunnel boring machine. It's a big piece of equipment, and it's designed specifically for the soil and rock you're going to go through. If you're
I'm going to show proof rock while we're talking about that.
Right. Yeah. So I mean, they're all kind of custom made, these tunnel boring machines. That's why they got names. They usually give them a name because they're made for that one job, and then they kind of that's them done. It's rare to reuse them. You might reuse the components, but you design it, with the cutting teeth and the speed of rotation, everything else that goes into designing a tunneling machine is specific to the conditions you're going to tunnel through. So the problem is if you've got some hard rock. You've got some hard limestone, and then you're going to hit a cavity which may be full of sand, and that's challenging from it's challenging. It's not. I mean, that's what the Port of Miami tunnel was like. It's just one of those things. It's kind of tricky. It's variable ground conditions. If you do enough investigation of the ground, you can kind of map out what you're going through. Then that would maybe that helps the tunnel boring machine designer pick his kind of worst case scenario and so forth. But the other thing is is groundwater. I mean, some parts of the aquifer are under pressure, so that can be again challenging for a tunnel boring machine if you've got pressurized groundwater. So to try and explain the pressurized groundwater condition, a lot of the lakes we have, particularly in the central Florida area, are feeding the aquifer. So they almost like reservoirs of water that are putting pressure into the actual aquifer system inside the limestone. So in other parts of, if you go into the limestone, you'll get a spring. Right. We have lots of springs in Florida, and that's the release of groundwater pressure is basically a spring. So that can be it's not insurmountable, but water is the tunneler's. It's difficult to tunnel through wet. It's done everywhere. There's lots of tunnels go through saturated ground. We don't just tunnel through dry ground. But again, you've got to manage the groundwater. You've got to make sure you don't contaminate the groundwater. There's other things you need to consider as you're drilling through it. So yeah.
No. So I've been to a spring in Denellen, Florida, near Ocala,
Okay.
called Silver Spring or Rainbow Spring. I forget which one. And
Mhm.
it's they describe it as something like 7 million gallons a minute are coming out of the ground and
Yeah.
feeding this river. Is
Right.
that rainwater somewhere else sinking into the ground and then coming back, or where's this water coming from?
Yeah. I mean, it's fed by rainwater. It's rainwater. Again, we have these sinkhole lakes, these circular lakes. They're not drained by rivers that flow out. So if you go to parts in northern US, you'll see as a river goes into a lake, and then it
Right.
maybe cascades out on the other side on a waterfall. We don't have that here. Our lakes are kind of little captive reservoirs of water, and they're sinkhole lakes, so they're in direct connection with the limestone because the limestone's collapsed and you've created this depression on the ground surface. So all our rainfall collects into these dishes in the ground surface, and then it flows slowly into the limestone below, and it keeps that pressure. So the spring is the expression of that pressure being released. It's where there's nothing stopping the water from flowing out. And these first generation springs you're describing there, where there's millions of gallons of water coming out of them, there, all that water is, it's a very small spring. It's a small area, but it's collecting water from a great, huge area around it with lots of lakes which are feeding that spring.
Okay, so real quick, Wyborn asks, because I think this is a question we're not going to answer, Wyborn. Could something like the Channel Tunnel be built across other large channels, water bodies, and how do tunnel boring company tech improve this process? I don't think we're going to go there. We're really talking about Florida geology, Wyborn, but thank you for the question.
Well, I mean, it's a reasonable question because the Channel Tunnel, I had some involvement in that back in the 80s. It's a tunnel through chalk. It's mostly through chalk, which is a limestone. Some of the challenges there were the chalk has flint in there, and the flint's very hard. It's you use flint as a Stone Age man used it as a tool. You can sharpen it and make arrowheads out of it. It's very hard material. Chalk's relatively soft, so the tunnel boring machine would hit these chunks of hard flint in the chalk, and that was a challenging thing. But again, it's underneath. It's a 30-mile tunnel through underwater. So
Right.
it's challenging, but it's, as I say, it's done everywhere. It's not insurmountable. There's very few tunnels that we have the luxury of doing in the dry. A lot of the Victorian tunnels back in the UK were done in the dry because it's hilly countryside. We don't necessarily find the groundwater, but
Right.
It's tunneling underwater is just one of those things. It's not something we can't deal with.
Right. No, and like the Japanese have lots of tunnels through mountains to get their bullet trains and other trains through because it's a mountainous country. So
Yeah.
I lived in Japan, so that's one of my things.
Right.
So I want to talk about the practical applications of this. So the number one, because I live in South Florida, the number one traffic problem I'm aware of is I want to go to Miami. I want to go to a Miami Heat game. Nobody goes to Florida Miami Marlins games anymore. But if I wanted to go to a Miami Marlins game, my joke is that the safest place from COVID-19 is in the stadium watching a Marlins game because there's no one there. They'll say there's 500 fans and you're looking around like they're exaggerating. They're the worst baseball team in America, but that's a lot. Maybe they're better this year. I'm sorry, I'm not being fair, but they have not had a good run. So forgive me for anybody who's a Marlins fan. I'm actually a Marlins fan. I'm just disappointed.
Yeah.
So, but we want to go to something in Miami. We want to go see the walls, the Wynwood murals. We want to go have the best Cuban food. Actually, my favorite Japanese restaurants are in Miami. There's a lot of great stuff in Miami, but you're driving down to Miami and there's this spot called the Golden Glades Interchange. I'm coming down the turnpike. Somebody else is coming down I-95. There's all these lanes that come together and it just always backs up. Even when there's relatively light traffic, it just backs up. And sometimes the drive down, it becomes I-95. That drive down I-95 just becomes a nightmare. And you're just stuck. And they added express lanes, and you can literally pay like $7 toll. It's like a variable toll depending on the amount of congestion. And somebody did ask about monetization. So I think the idea is if you created a loop underneath the Golden Glades that took you to various spots in Miami where people go, then people would pay a toll just like we pay a toll for the express lane now.
Right.
So my impression, and just so you know, I don't know how familiar you are with the Boring Company. My understanding is, and a couple of things that you said, I want to address a couple of things. One, the Boring Company tunnels are 14 feet in diameter.
Right.
And then they put 300, actually, this is part of my conversation with Will last time. They put these concrete segments on the outside as they go through to shore up the tunnel.
Right.
And Will said they're 300 millimeters or 30 centimeters or about a foot thick. So that reduces the effective diameter of the tunnel to 12 feet because you're putting these segments. And Will thinks they may get to a solution where they're able to go down to 200 millimeters or something, and that would give you a little more width. But so we're boring 14-foot tunnels is the issue there. And you said, it was very interesting, you described it as the boring machines are sort of like one-offs. You build a boring machine for this purpose and you stop. And we believe the boring company plan is to manufacture, I don't know how long the boring machines will last, but to basically mass produce boring machines. We've said we're doing 14-foot diameter. That's what we're doing. I'm sure the cutting heads are going to vary depending on the surface you're cutting through. Some of the other applications are going to matter. Does it seem practical for starters there to get to a point where you... Because here's the thing. If they increase tunneling speed and they lower tunneling cost, they may make it much more economical to use tunnels. And Will said they're down to $7.7 million a mile in their Las Vegas project.
Yeah.
You could end up with saying, we're going to do a much bigger project. We're going to mass produce, 16 machines. We're going to drop them in at these points and connect all the tunnels up. Does this seem like something that's practical that could be done?
Yeah, I mean, I think particularly in Florida, because, again, we don't have those very hard rocks, really. I mean, it's relatively soft rock. So you could imagine there's a tunnel boring machine that's designed to go through, say, South Florida soils and rocks, or even Central Florida soils and rocks. It doesn't need to be. You could use it in multiple applications. I'm sure you could use. It could be reused, and because it would. We don't have big chunk of granite we're going to suddenly come across that we're going to have to change the tunnel boring machine for. It's all relatively straightforward soils and rocks. So yeah, I think it seems reasonable. That the problem is going to be how deep do you need to go? I mean, and again, if you're going through underneath Golden Glades, every one of those overpass bridges is built on piles, and those piles might be 100 feet down.
Right.
So you either got to skirt, or, you got to kind of find a way past all that, and then nip in between a big hotel which is on piles and things like that. So that could be a challenge. But I think it's certain everything's doable, isn't it? I'm not an expert on monetarization of how these public works projects are funded, and I know of course the Miami Tunnel was $1 billion, wasn't it? It was a huge expense for a relatively short tunnel, but again, there's a cost benefit to that tunnel being in place, and particularly for the port and the commerce that's generated through that port, it's worth doing. So
it sounds like from our earlier conversation, it sounds to me like as long as the boring company is able to go with a consistent depth. Let's say they're going to go 40 feet down. I'm just picking a number. Let's say they're going to go 40 feet down or 50 feet down. They're not likely to encounter really large changes in conditions. They're not going to go from soft rock to granite and back.
Right.
There may be points where it's wet and points where it's not, but that would allow for more consistent tunneling, and they would be able to be more effective. Does that sound right? Exactly.
Yeah. That's precisely that, isn't it? Because as I described before, most of the soils and rocks in Florida are relatively horizontal, so you can pick the layer you're going to drill through, if you like. You're going to tunnel through this particular layer. Again, the challenge with the Port of Miami is it was steep. It went down, it came back up again. So it crossed through those different layers of soil, and some were hard, some were soft. So that was a challenge there. But if you're picking, right, I'm going to go through this clay which sits above the limestone, I'm going to tunnel through that. Then that's, again, depends how long the tunnel is, but relatively consistent geology should be encountered at that kind of depth.
So when they bore this, my impression is when you bore a tunnel and you put this concrete segments up, when they design the tunnel, they make it watertight, right? It's not going to flood from the water around it.
Correct, yeah.
And is that a big challenge because Florida rock is more wet? What are the challenges because they're more likely to encounter wet circumstances?
Yeah, I mean, there's challenges because it's buoyant. So it's an air-filled tunnel, so it's buoyant. So you got to make sure it doesn't deflect upwards. And, as one of the challenges with Florida is that we have these rainy summers, and, you get 6 feet of rain over a wet season. So the water table varies by 3 or 4 feet just naturally with rainfall. Now, that if you're not deep enough and kind of locked in enough that, that's an impact. So if you're relatively shallow, it's kind of like if you drain your swimming pool in the summer, your swimming pool can pop out of the ground if you drain it completely and there's a storm and, water table rises, it can pop your swimming pool. So you've got to overcome that buoyancy with the tunnel, which is, it's heavy enough. And sometimes, some tunnels, you've got to kind of anchor them down. You've got to use an actual foundation below the tunnel to hold it down so it doesn't pop out of the ground and, in the saturated water conditions. So, but yeah, again, it's part of the design, it's a balance. You make the tunnel, it's heavy enough that, you don't, even though it's an air-filled cavity beneath the ground, it's not going to, pop out as the water table changes over time. You just do that calculation. So. Okay.
So it's an engineering challenge.
It is, yeah.
Okay, so Ben Pena asks, are those, so I don't know if you've seen this, on the Boring Company FAQ page, they have some pictures of, or renderings of what stations will look like. And one of the renderings is basically a hole in the ground with a stairway down to a spot where you would be able to access a very small station for a place that has low population density, low traffic. And Ben asks, are those open underground stations a good idea in a wet climate like Florida? And I'm guessing you're saying that's an engineering challenge as well.
Yeah, you've just got to waterproof it. It's the biggest basement you're ever going to build. But yeah, you can make it waterproof. It's not something which is impossible. I mean, probably a good example is maybe the London Underground, the tube in London. I mean, there are stations like that where it's basically just an escalator taking you down to the station. It's a very small station. There's nothing down there but a platform to get on the train. So that would work. In these more sparsely populated urban areas where you just got some access point. But again, the London Underground, it's pretty wet ground down there. There's next to the River Thames, you go underneath the River Thames, there's gravels that have been deposited on top, so they're water-bearing strata. So there's challenges, but you don't worry about in the tube, you don't worry about getting wet in the station, even though it's some distance below ground. It can be done. It can be sealed. It can be waterproofed.
Okay, so. One of the other things that I wanted to talk about is my fantasy. I'm not a theme park person. I don't go to Disney. I don't go to Universal. I've been, and I don't particularly enjoy the experience. Standing in line on hard concrete for hours is not something that appeals to me, but my kids like it. So I have this vision of, other from population centers like South Florida, or maybe from Jacksonville or even Atlanta, these, long distance straight tunnels with higher speed vehicles, whether it's trains or, pods or whatever we're going to call them, traveling to destinations. I honestly, I think Disney and Universal and Orlando are this massive destination that lots of people want to go to. And I envision, I walk out of my house, I hop in a Tesla robo-taxi. 5 minutes later, I'm at the Hyperloop. And the Hyperloop takes me to Disney in 15 minutes or less, and I walk out. I've spent $20, and I go to Disney for the day, and then I come home that night. I don't need to stay in a hotel, and that could massively increase the business of theme parks. Is the one side of it. Is it? It sounds like because of Florida geography, it might be easier to do that long straight tunnel because, especially if you're not varying the height of the tunnel, you're going to be encountering more consistent material as you go through.
Right. Yeah. I mean, because the thing is as well, you don't have that topography at the ground surface really, because even I'm here in Orlando, 100 feet above sea level. You're in South Florida, 10 feet above sea level. But there's not much really over that distance, so you can overcome that. The tunnel wouldn't need to be designed for being under great distances of material above it, so you don't have to make it strong enough to hold up, 1,000 feet of sediment above you, so it's a relatively straightforward design from that point of view.
Right. Now, what about the Florida Everglades? We don't make roads through the Florida Everglades anymore. Could we make tunnels under? Is there some level of depth you'd need to go down to avoid disturbing the environment of the Everglades?
Yeah, I mean, the Everglades is there's not much limestone there. You're mostly in kind of a sandy material, which is the Everglades is kind of, if you imagine like the Mississippi Delta, it's an ancient delta system. So there's rivers of discharge from the end of Florida and discharged out into the Florida channel there. So So it's mostly sandy material. So yeah, you wouldn't have any impact really on the surface, because that ecosystem really just, as long as you're not disturbing the groundwater or polluting the groundwater, do you have to build ventilation tunnels? Are there other things you need to put in at the surface? Maybe that would have an impact. But again, a relatively small footprint. So
would you want to go deeper to get to different? Is sand easier to tunnel through than limestone, or is there limestone at some level down?
Yeah, eventually you get there. But it's easier to tunnel through because it's a softer material, but it collapses more readily. So you've got it's the support of the ground above it which becomes the challenge. Then you don't. But then again, if you're just causing some minor subsidence at the surface, and you're in the Everglades, what does it really matter? If you're going through an urban environment and lots of buildings there, but people who are going to sue you if their building cracks for some reason, then so that's a kind of a different challenge. Obviously there would be. You would argue there'd be some impacts, but compared to putting a road through there, or even a road on a bridge, so that the water can still flow underneath it, you could put it as a causeway going through the Everglades, but it's not pristine anymore, is it? If you've got something going through, a bridge going through there.
All right, so this is a good question from Will from A Boring Revolution. Hi, David. I'm guessing that if the boring company built a few tunnels under Florida, they would greatly enhance everyone's understanding of the local geology via the data they collect. Does that sound correct?
Yeah, absolutely. Yeah. So, we understand our geology based upon, mostly just drilling holes that are 3 inches in diameter and taking soils out and looking at them, because, we don't have geologic outcrops. If you go to Colorado, you can go and see the rocks. You can map those layers.
Right.
We don't have outcrops of anything really in Florida, except in the springs. We see the limestone in the springs. So most of the rock is just covered by sand. So we base our understanding on just drilling holes and taking samples out. Any major infrastructure project, it collects a huge amount of geologic data to be able to understand what you're going to either build on or tunnel through in this case. Okay. So yeah, it would vastly improve the understanding, and a lot of scientific data. If it's made available to everybody, it's great research material.
Okay, so from my conversation from Will from reading Boring Company materials, one of the big challenges of tunneling is when you're done, as you're tunneling through, you're generating all this material that you're taking out, and what do you do with it? And the Boring Company has this idea, which I think might be less successful with Florida than it would be with other places, that they could take the material and convert it into bricks. And I think when you're using hard rock, it's easier to turn it into something useful. When you're going through soft rock, it's harder. It's less useful for making bricks. Would the material coming out of tunnels done in Florida, and let's say the limestone in Miami, what did you call it, oolime?
Yeah, the oolite. Yeah, oolite.
Would that be something that could be used to make bricks, or that you'd pretty much just have to dispose of it?
Yeah, I mean, obviously South Florida has a lot of quarries where the Miami limestone is quarried out, mined out, and it's crushed and used as road base. And as a construction material, it's used as aggregate. So yeah, you could certainly reuse it. The sand is probably, again, if you're going to build a subdivision, you may need to import fill to raise the house pads up. So there's always a use for material. We don't have to landfill it. You can reuse it as a construction material relatively easily. Now, I think again, Port of Miami tunnel, I do believe there was a little bit of an issue there with some of the spoil material that was generated from that. Was there was some of it wasn't put where it was supposed to have been put, and
it's Miami. They don't do anything right in Miami.
So obviously, again, it's a material, it's a waste material, but it's a natural waste material, so it hopefully shouldn't be contaminated by the tunneling process. But
hopefully we're not uncovering any plutonium or uranium or other danger. Is there any radon down there? Is there any toxic materials in Florida geology?
Yeah, we got radon. I mean, it's more probably sort of the again West Central Florida, the phosphate mining industry. The phosphate ore is mildly radioactive. So we do check for radon gas in certain parts of West Central Florida, Polk County, Hardy County, those places. So yeah, some of it, and we've got titanium mining up in the Jacksonville area. So there are deposits which are can be a little bit less than wholesome, shall we say?
Okay, so a couple questions or comments here. So I'm going to read you both of them. We can talk. I think they're related. Tramp Fossil says, what about the pre-existing tunnels and aquifers. And Skywave DXer says, Florida is a honeycomb of caves and springs, which are part of the environment and tourism. So just because it's possible doesn't mean it'll be allowed. I'll just comment really quickly that Skywave, I think both of you are really talking about not South Florida. That one of my primary objectives is South Florida. I don't think there's a lot of people. I don't think there's a lot of springs there's not a lot of tourism in the Everglades that would be disturbed by anything south of, say, Lake Wales. Making up a location. And I don't think there are a lot of pre-existing tunnels, but I think I asked you about this before we started. What about aquifers? What impact does tunneling have on aquifers?
Well, I mean, let's talk about South Florida first. You've got the Biscayne Aquifer there, which is, you've got a challenge with water supply in South Florida. And again, I said to you earlier, we sit on one of the best aquifers in the world, but South Florida, you've got a lot of problems with overuse of that aquifer, a lot of, over exploitation. So you're dragging in salt water from the ocean because you're pumping too much of the fresh water out. And again, but the impact of tunneling, I mean, you have to control water while you're making the tunnel. You have to have some system in place. I mean, there's different ways of doing it, but I mean, you shouldn't be you won't be removing any water from the system. You just be putting a concrete tube through the ground and the water's going to flow around it. You just got to be careful that you don't contaminate during that, because it's machinery. It's, there's fuel and things that can spill. And so you do have to be very environmentally aware that you're not going to contaminate the ground that you're boring through.
Right, and just really quick, the boring company is using all electric equipment, no diesel machines, and the vehicles that will be going through a boring company tunnel will be all electric, battery electric vehicles. So they're less. I think they're aiming towards having all electric in the construction of the tunnel, and the use of the tunnel will be all electric. So there's a lot less concerns about that kind of problem from boring company tunnels than others.
Yeah, fabulous. Yeah. I mean, you don't have to worry about, you put a petroleum tanker on a train and run it underground on like the Channel Tunnel.
I don't think they're doing that.
No.
Yeah. But there are parts of Florida where there's a lot of. We actually talked a little bit about this, the caves and the scuba diving in the caves.
Right.
So what impact is it? Just that you would tunnel around them or plan your tunnel so you don't interfere with that? Is that a big challenge or a small challenge? I don't know how big that is.
Yeah, I mean, some of the springs are relatively close to the surface. Always, they discharge. You can get into the limestone and swim and scuba dive through it. So there you're going to be probably, if you have to tunnel in those sort of areas, you're probably going to have to go deeper down. And there's going to be, I don't know what the environmental, assessment would involve for that, really, because it's the springs are protected. There are water supply. If we mess with the groundwater supply, not only do we impact the environment, we impact our water supply. The stuff we use to, everything from irrigating crops to drinking water will be impacted. So. Our Florida population is increasing rapidly, and there's more and more demands as days go by on the aquifer. So you have to make sure that any infrastructure you put in the ground can't impact that critical resource that we have here.
So here's a really interesting question from Dave Keller. And I think I've talked with somebody about this issue somewhere else before. What about using the tunnels as pipes to move water around? So let's suppose there's a surplus of water in North Florida and there's a shortage of water in South Florida. My impression was there's actually negative environmental consequences from taking water from one place and moving it to another. That's not really number one, you're enabling South Florida's abuse of its water supply, which, can I tell my HOA, hey, I don't want to water my lawn because I'm trying to protect the environment? If you changed HOA rules, we could solve a lot of these problems. But is that a viable option? Would a 12-foot diameter tunnel carrying water from places that have it to places that don't, would that be a solution?
Yeah, I mean, that's the old solution. What was done back in in the 40s and 50s was build canals.
Right.
So you transport water to South Florida by a system of canals, which the Corps of Engineers built. And that's why the Everglades suddenly started to dry out because rather than the water kind of meandering down, say the Kissimmee River or something like that, it's a slow-moving, meandering river because it's slow-moving because we're relatively flat.
Right.
They built these straight-line canals, and the water gets there a lot quicker.
Right.
But it doesn't do what it used to do. So then you have flooding problems because there's no storage in the system because it's kind of rapid movement of water from one place to the other through these man-made canals. And tunnels are used, infrastructure tunnels. Even Disney World has a system of tunnels underneath it that they use to move things around and people around and power and water and sewage is through an underground system of utility tunnels.
I did not know that. Okay.
Yeah, you get a magic kingdom. There's a lot of people underneath your feet.
It's a magic kingdom. It is.
Here we go.
Okay. So if you were to think about this like optimistically and say, hey, let's suppose we got tunneling down to $1 million a mile. Do you have a sense of how it could make not just for South Florida now or Florida in general, but how could that make our lives better for, because I think it's about $1 million a mile to make a highway lane. And
it could be, yeah.
And so it's just things like I'll guess my own spin is, if you get to a certain point, you might we have a road. It's called the Alligator Alley that goes from Fort Lauderdale to Naples, basically, or west into Naples.
Right, I-75. Yeah.
It is a road that cuts through the Everglades and probably has environmental consequences for the Everglades. Just the fact that the road's there, that somebody has a gas leak or an oil leak there, or it interrupts the flow of animals and water through the Everglades. Right. I almost think if you did tunneling, you could pull that road up.
Yeah. Well, I think if you tried to build Alligator Alley today, you wouldn't be able to. You'd have to build it as a causeway so that the water and the wildlife could pass underneath it. And I've done some jobs here, and where even like a 4 or 5 mile long section of road had to be put on stilts effectively, so that there could be a passage of water through it, because the road does interrupt the flow. You can put culverts and drainage features underneath the roadway, but I mean it's still going to. If you imagine all the water trying to flow in one direction, then you're going to channel it into these kind of culverts that go under the road, and then it goes out again. It's just really has a big impact on the drainage around. So I don't think you'd be able to do Alligator Alley these days. It'd have to be a different design altogether. So again, that's what you maybe think. But well, to build a highway on stilts for across the entire width of the state is prohibitively expensive.
Well, that's what I'm saying is if you did say, let's say we decided, we're gonna run some tunnels. We're gonna run 4 lanes of tunnels each way to Naples. So we'll have 8 lanes of tunnels to connect I-75 from Fort Lauderdale to Naples, and we're gonna wipe out the existing Alligator Alley roadway and restore that to nature.
Yep. It
would cost a lot to take out the roadway and restore it to nature, but that could be a huge environmental benefit, and also, and maybe, I mean, it's a straight shot. It's a pretty easy drive the way it is now. That's just one idea that pops in my head. Can you think of other things that this tunneling can do that would make life better for people and make the environment better, the world better?
Yeah, I mean, I think societies get to a stage where mass transit is needed, and in America we love our cars, don't we? We like to jump in our car and have our personal space and drive places. I come from the UK, and I'm much more used to public transport and using light rail and tube systems and underground rail, so. I think it's a critical mass of population in certain areas, isn't it? That's a lot of Florida. You can drive for miles and not see anybody. It's still kind of But if you get these I don't know, it's 4 million people in Miami-Dade or whatever, a big concentration of people, then using the car becomes less attractive, and it has an economic impact because people, rather than doing the job, they're sitting in the car. They're spending more time getting to work, and their quality of life is lower. So I think you see the benefit first in the more densely populated areas, and then the connectivity to let people go to from one side of the state to the other, go to Disney World. That's something we as a society would think of having value. And we as engineers and geologists can make anything happen. We can. Right. There's always a way of doing something, but the society has to. I mean, I'm a bit philosophical here about it, but society has to see the benefit of it, and the cost has to, sit well with people's concept of particularly public funds being spent. I mean, private funds may be different. I don't know.
Right. And are you in the Orlando area or the Tampa area?
Yeah, I'm in Orlando. Yeah, which is 2 miles from Walt Disney World.
Okay. so again, unfortunately, I put everything in terms of my own context because that's what I see, and I could see this relating to Orlando as well. A lot of kids from my local high school. I have a freshman in college and a freshman in high school. A now sophomore in college and a sophomore in high school.
Right.
A lot of the local high school kids go to University of Central Florida. They go to Florida State, and they go to University of Florida. Those are and USF. There's four. And then of course they go to FAU, which is local. And there's probably a lot of kids from Orlando maybe who go to FAU or go to University of Miami. One example that I could see is you could connect the universities with that would be they're very high population, they're fairly dense population around universities. There's a lot of economic activity around universities, and the trip. I'm guessing you would have the same issue if you go to Tallahassee when I-75 meets I-10. It just sometimes it's a nightmare of traffic.
Yeah.
Elon Musk's take is the purpose of these tunnels is to save us all from soul-crushing traffic, but I think it's also the goal. I think the larger goal of Tesla, the Boring Company, everything else is if we can reduce the cost of transportation, we improve economic efficiency. We make the economy work better. We make the economy more productive. Like you just said, instead of sitting in a car doing nothing, you're now productive. Or if we have self-driving cars, you can now be productive or enjoy yourself while you're riding in a car that's driving itself. Yeah. And if you're in the tunnel, it's a lot easier to make autonomous driving work if there's no intersections.
Exactly.
If there's no cars coming the other way, there's no pedestrians. There's a lot of prospects here. Oh, here, let me just see. We have a question. Mohs scale of hardness fits here. I don't know who Larry and Curly are. Are you familiar with the term Mohs scale of hardness, and what does that have to do with anything?
So, I mean, Mohs scale is a scale from 1 to 10 of the hardness of minerals. So there's different. So, the hardest is diamond at a 10, and the softest is maybe talc. That's a mineral, but it's something you can, dig out with your fingernail. So it's a relative strength of material. So quartz, I think it's about a 6 on a Mohs scale. And the rest of the Marx Brothers, I don't know much about. But
okay, so Mohs is not a reference to the. So what is the hardness of the Ulime, the rock in Miami?
So it's calcium carbonate base. So it's calcite would be the mineral. So that calcite, I think it's around about a 4 on Mohs scale. You're taking me back to my undergraduate days here, but okay. It's about a 4, I think. So you can it's not as hard as quartz, but it's stronger than talc.
Something you said earlier struck me that I wanted to come back to. I meant to come back to it, and I finally coming back to it now. You said that Florida's limestone is 3 miles deep.
Yeah. Is
that the whole state, or is that vary?
No, pretty much the whole state, yeah. So it's the Florida platform as it is. It encompasses the whole of Florida. It goes out 60 miles from Tampa into the Gulf of Mexico. It kind of drops off fairly steeply out by you guys in Miami there. That's the edge of it there. But it's a zone where it was very perfect conditions for limestone to accumulate, and it did it for millions of years. And it's hard to sometimes hard to understand. Why would you have 3 miles of thickness? I've said to you earlier that limestone forms in very shallow, clean water. So typically 100 feet of water is the optimum environment. So, we know the sea level hasn't changed by 3 miles, because that's crazy. I mean, it has changed by several hundreds of feet. But the thing is, when the Atlantic Ocean was rifting apart, it made the crust under Florida thinner. So the crust deflects under the weight of the sediment. So as you accumulate more limestone, then the crust is giving way and sagging down. So you still keep that kind of 100 feet of water, but because of the Africa's going off that way and the Atlantic Ocean's opening up, it's stretching the crust below us. And it allowed, it's kind of like standing on a trampoline, the crust deflected and we kept accumulating more and more limestone over millions of years.
So that's tectonic movement moving away, leaving space for the limestone to go deeper.
Yeah. So, I mean, Florida's a bit of an orphan, really. Most of Florida really should be with Africa. Africa left us behind when it kind of spread out across the Atlantic. So if you drill down, in parts of Florida, you're going to find a granite very deep. There's a granite down there called the Osceola granite. which matches to a granite in West Africa. It's the same material. We just got we got left behind when Africa left.
So if we have 3 miles of limestone, going with Elon's theory that you can, I think he used it, I don't think he used the word infinite, but you can go arbitrarily deep in your tunneling. Does that mean we could, in theory, go tunnels down as much as 3 miles and still, we could have this massive network of tunnels miles deep? Or is there a point where that becomes impractical, or is the pressure from above create problems?
Yeah, I mean, it's just too damn hot, really. It gets really hot the deeper you go. So if you go to, I mean, you've ever been down to, I've spent some time in coal mines and things like that, and metal mines. Once you start going deep, it gets really hot really quickly.
And that's geothermal?
Geothermal gradient. There you go. Yeah. So so that becomes an issue. It would be impractical to, and then you've got to ventilate as well. You've got to get air in there. You can't, even though you're moving quickly through there, you still need if something breaks down, people can't suffocate. So
right.
So you'd have to ventilate it somehow. So yeah, I mean but when people do dig, very deep, diamond mines and the like in South Africa are incredibly deep. So it can be done, but it's kind of tough environment down there.
Okay. Well, I'm enjoying this conversation. I'm sort of running out of things to ask you. And SpaceX is bringing their capsule from the International Space Station. And I believe that they're going to start deorbiting in about a half hour.
Right.
I think it's going to start entering the atmosphere in about a half hour. So I thought Thaddeus mentioned geothermal gradient. Let me just ask you that really quick, because that did pop in my head, Thaddeus. With the heat in the tunnels, is it conceivable when you tunnel, you could use it to generate some kind of energy using that heat? Or would that be extremely difficult to pull off? Or is that an engineering problem beyond your knowledge?
No, I mean, yeah, that's what geothermal energy is all about. It's a heat exchange. So we got geothermal wells in, houses in Florida that are powered by geothermal, just by drilling a well down and just using that the heat exchange to generate power. So I mean, absolutely, it's possible. Okay. Again, it would be how you do it, I don't know.
Right, that's the engineering challenge, and maybe they use the octovalve from the Model Y, and somehow that does it. So
yeah, there you go.
David Wilshaw, I want to thank you very much. I don't think I did it yet. I will put a link to your company website, Britannia Solutions LLC, in the description to to this video. Really appreciate you coming on. I would encourage anybody, if you need geological help, and I did have other stuff I wanted to talk to you about, but I want to watch the SpaceX stuff. And I kind of, like, this other stuff I wanted to talk about wasn't really relevant to the Boring Company, and that was the purpose of the video. So listen, thank you very much for coming on. I really appreciate it. Thanks everyone for watching. And David, I'm going to end the stream and I'll talk to you a little bit.
All right. Thanks, Warren.
Appreciate it. Stay on for a second, David.
All right.